Welcome to this presentation of Caldera's EasyMedia color profiling software. EasyMedia allows you to calibrate a display or a printer. First, select the type of peripheral you want to calibrate. Now select the specific device you wish to calibrate. For this demo, we will calibrate the Epson GS6000. Now select a media from the list to calibrate, or click on the New button to calibrate a new media. First, name your new media. You can also enter cost information, or have Caldera compute that information for you. Enter the roll's width, roll's length, and cost of the roll. Caldera will compute the cost per square meter of your media. Under Parameters tab, you can enter specific settings to be used with this media, such as horizontal and vertical compensation and heating system settings. Click on the Next button. You'll need to create a new mode and resolution to profile the media at. Click on the New button. Select the mode. For this printer, we can profile in CMYK, CMYK plus light inks, CMYK plus orange and green, or CMYK plus light inks in orange and green. Select the resolution and the quality. Again, under Parameters, you can enter specific settings for this media and mode resolution combination. Click on the Next button. This next screen tells us the status of our project. For this example, we have no transition curves, no linearization curves in Inclement, and no ICC profile. This is because we created a new media. The profiling process for this particular printer consists of 4 steps: transitions, linearization, global inclement, and profiling. Click on the Next button to begin the calibration process. The first step of the calibration process is to create new transition curves. We will run the wizard to print, measure, and build these curves. On this next screen, we need to select the device as well as the targets we will use. Select your device from the list and select your targets. Click on the Next button. On this screen, we can adjust our print settings. We can choose our roll, as well as quality and scale, and then click Print. You can adjust the same settings for the dark ink targets, and then click Print. The next screen will begin the calibration process for our transition curves. Connect your device and click Start to begin measuring the targets. The same process will be repeated for the light and dark ink targets. In this step, you have the option of entering a specific value at which you want to stop the usage of light inks. You can go on to the next step, and Caldera will by default compute this automatically. The next step allows you to enter a value where the dark ink density is high enough to stop using light inks. By clicking on the Next button, we are able to see the final curves in graph format. The top curve represents the light inks and the lower curve represents the dark inks. With this graph, we can see that as more dark ink is used, less light ink will be used. It is possible to manually adjust the curves by dragging them. In some cases, you may want to keep a small amount of light ink until the end to cover any empty areas that may be visible when printing at low resolutions. By lifting the light ink curves, you can have the printer use light inks until the end. When you are finished adjusting your transition curves, you have the option of printing a test target. If you wish to do so, click Next and select your target. Set your printer settings and click Print. If you are satisfied with your printed target, you can select Satisfactory and skip to the next step. If not, you can go back and adjust your transition curves. The next step is linearization. We will select to create new linearization curves, and we will run the wizard to print, measure, and build those curves. On the next screen, select your device and the target you wish to measure. Next, set your print settings and click Print. Once the target is printed, you can click Start to begin measuring the target. The next screen represents the results of our linearization measurement. Caldera will adjust the amount of ink used when the ink's density reaches 99%. Individual ink channels can also be adjusted in this step. It is recommended to set each channel at the point where the curve begins to become flat. This can be done by selecting and moving the point. Depending on the media you are calibrating, you might need to adjust the curves to use more or less ink per channel. The linearization curves can now be evaluated graphically or numerically. If the curve is smooth, you can continue to the next step. However, if you notice jagged points or bellies in your curve, it might be necessary to remeasure the linearization target or adjust the transition curves. If any changes are made to the transition curves, it will be necessary to reprint and remeasure the linearization target in order for the adjustments to be taken into account. When you are done with the linearization process, you will be given the option to print a test target. Select Yes to do so, or select No to continue to the next step. Next, we will set the Global Inclement. This is a visual test, therefore a spectrophotometer is not needed. Select Set up a new inclement and run the wizard to do so. Click Next, and on the next screen, select a target to print. Set your print settings and click Print. There are two things you want to look for in the printed target. The first is over-inking. If you see over-inking, set the ink limit to the step before over-inking occurs. If you do not see over-inking, limit the ink at the step where the ink is darkest and does not benefit from using more ink. A percentage scale is printed at the top of the ink limit target. After you have selected the best step in your target, enter the percentage of the selected step in the next screen. The final step of the calibration process is profiling. In this section, we will create the ICC profile. Click on Create a new ICC profile. We will run the wizard to create our profile. Then click Next. You will once again need to select your device and profiling target. Choosing a target with a high number of patches will provide a more accurate profile. However, if you are creating a profile at a low resolution, scanning more patches will have little effect. Click Next to continue. Set your print settings and print the target. Next, measure the target. This screen allows you to set up your profile and its behavior. First, select profile size. Medium is usually sufficient for most profiles. Large provides a bit more accuracy, but with increased file size. Setting this option to medium will result in a file of about 2 megabytes, making it easier to transfer via email. Large will create a profile of about 8 megabytes. We suggest setting gamut mapping under the perceptual rendering options to default. This will render images as realistically as possible, with the highest color accuracy. There are other options that can be used to produce more vivid or saturated colors, but these will be less accurate. Next, you can set the smoothness accuracy balance. This will allow you to balance between the smoothness of gradients and the accuracy of colors. The more accurate color is, the less smooth your gradients will be. For general purpose profiles, balance is usually the best choice. If you are creating a profile to be used to print only Pantones or only gradients, you can adjust the setting accordingly. Finally, select your viewing light source. The next step determines the behavior of black ink. There are several options for the separation method. With the exception of no black, the farther you choose from the right, the more black ink will be used. The default setting is GCR2 with a black start of 20%. Our testing has shown this produces the largest possible gamut. The max black option can be used for grayscale printing when it is useful to use more black. For a grayscale dedicated profile, you can use max black with a black start of 0. This will use the maximum amount of black ink, resulting in a neutral grayscale. We will set the separation method to GCR2 with a black start of 20 for our demonstration. Be aware that adding more black ink and using an early black start will result in graininess because black dots will be used even in light colors. This will also result in less vivid colors. When you are finished, click Next to build the profile. In the left part of this window, a CMYK image is displayed. It is a soft-proof preview of an image using the profile that has just been computed. We can click the Disable Profile button to preview the same image without the profile. Self-Gamut measures the internal coherence of the profile. It is the average delta E you would get if you printed all the in-Gamut colors of the profile. Gamut Swap is the average delta E of your profile compared to the swap gamut. It is a very quick indicator of how well your media will render swap colors. Viewer allows you to analyze the gamut of your profile. The gamut of the profile can be compared to another printer, media, or industry standard color space. The gamut can also be previewed in 3D by clicking on the 3D button. Once the profile has been generated, it is recommended to print a test image that has a combination of CMYK and RGB images, spot colors, grayscale images, gradients, and skin tones. Caldera provides a file that can help you test the quality of your profile. When selecting your test image, remember that you can also choose a file from the image bar and drag and drop it into EasyMedia. If the test image prints correctly, you have successfully completed the profiling process. Be sure to save the media project.